Today we are surrounded by a vast range of materials with variety of properties. A single item can be made of different materials, like the Boeing 747 jumbo jet is approximately 1% fiberglass, 4% titanium, 13% steel and 82% aluminium. Or a single material can have different properties, like the glass on your screen where you are watching this video is different than the glass from which you drink. Yet there is one thing common in all materials. They are all made up of atoms. Atoms may differ from one another, but all atoms are made of three basic particles: the electron, proton, and the neutron. Thus, in order to understand the property of any material, it is necessary to understand atoms, that is, atomic models. The first model of atom was proposed by the British physicist J.J. Thomson. He was also a Nobel laureate in physics because of his discovery of electron, the first subatomic particles to be discovered. He proposed this model in 1898, which is also called as the plum pudding model. According to his model, the atom was a sphere with uniformly distributed positive charge and the negative charges embedded on it like the plums in a plum pudding. This explained charge neutrality of atoms pretty well, but it was inconsistent with the results of experiments performed later on. Thus, it was discarded. Then a New Zealand-born British physicist, Ernst Rutherford, proposed his model of atom in 1911. He and his students performed the famous alpha particle scattering experiment, in which they bombarded alpha particles on a thin gold foil. They observed that many alpha particles passed through the foil without being deflected, but some of them deflected through large angles. In order to explain this, and inspired by the orbital motion of planets around the Sun, he proposed his planetary model of atom. The atom consists of electron orbiting around a positively charged massive center, the nucleus. This had a serious consequence though. The electron, as spiraling around the proton, would continuously radiate energy and gradually fall into the nucleus. This makes the atoms unstable, but atoms are stable. His model was not entirely discarded. In 1913, a Danish physicist, Niels Bohr, combined Rutherford's planetary model, Einstein's photon concept, Planck's quantum hypothesis to propose a model for hydrogen atom. He suggested that an electron in an atom moves in circular orbit around the nucleus due to Coulomb force of attraction between them. The electron only revolves in certain allowed stable orbits around the nucleus, where it does not radiate energy. These orbits are called stationary orbits. The stationary orbits have orbital angular momentum of the electron L as integral multiple of h cross. Atom radiates energy only when electron jumps from a higher stationary orbit to a lower stationary orbit. That is, emission or absorption of radiation occurs only when electron jumps from one allowed orbit to another. Bohr considered the principal quantum number, and using his model, Bohr could very well explain the energy of the electron in the stationary orbits, radius of the permissible orbit for the electron, velocity and orbital frequency of the electron in these orbits, the frequency of radiation emitted and the frequency of radiation absorbed during transitions between allowed orbits. He could also explain the spectral lines of hydrogen atom, namely Lyman, Balmer, Paschen, Brackett and Pfund series. Even though he successfully explained a number of experimentally observed facts and correctly predicted the spectral lines of hydrogen atom and singly ionized helium atom, he failed to explain the spectra of complex atoms, the distribution of electrons in the atoms, the selection rules which apply to the transitions of electrons, splitting of spectral lines in presence of electric field, that is the Stark effect, splitting of spectral lines in presence of magnetic field, that is the Zeeman effect, and the fine structure of spectral lines. Although Bohr's model is at present considered naive and outdated, some of its features are still used unchanged, while others have persisted at least in a modified or qualitative manner.